start by dividing the two. Sorry for just starting the video. Forgot to for A and B. You can look at them and probably catch on. But we are solving by extracting square root. So we've got x minus 5. That quantity is still being squared, is equal to, what's 72 divided by 2? 36. Now, before I add the 5, what do I have to do to both sides? I have to take the square root of both sides. And so I get x minus 5 is equal to, being I got rid of the squared, I have to list not just 6, but plus or minus 6. Now what do I do with the 5? Add the 5. We get 5 plus or minus 6. What's 5 plus 6? And 5 minus 6? Negative 1. So you can see the two solutions that you get, 11 and negative 1. So because we had to add the 5 over, it'd be 5 plus 6 and 5 minus 6. All right. Letter D, what do I do first? Before I divide by 5, I will add the 4. I get 5x squared is equal to 14. Now what? Before square root, I divide by 5. X squared is equal to 14 fifths. Now, square root. What's wrong with leaving the answer like this? So, in order to get rid of the square root on the bottom, Ashley, what do I have to do? Yeah. Then we get x is equal to plus or minus. And the square root of 14 times square root of 5, that ends up being square root of 70, which can't be reduced at all. Over 5. So that's our final answer. What do you notice about all these solutions? What do they all have in common? Plus or minus. There's always two of them, right? The squared tells us that we should have how many solutions? 2. That's back to that fundamental theorem of algebra. So, remember this? Okay. We'll practice a little bit of that today in our assignment. Another thing we want to practice is, let's say something doesn't factor. We're going to need to use a quadratic formula. The quadratic formula says this. If you have ax squared plus bx plus c, and you set it equal to 0, the solutions for x end up being negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Remember that? Can you sing the song for us? Oh, I agree. Take it away. Can you give me a little gist of it? I feel bad because I'm a math teacher. I've never heard the song. Dun, 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 dun. X is equal to negative b plus or minus the square root b squared minus 4ac all divided by 2a. Something like that? Is that I just took it away. Some people have gifts and talents, and that's kind of, you can tell mine is in arts, right? Okay, no. All right. Well, here we go. So what we do is we make sure it's set equal to 0. That's most important. And then we identify a, b, and c. A is going to be the number in front of x squared. B is the number in front of x. And c is the constant on the end. So I will set it up. X is equal to, what is negative b? negative 8 plus or minus the square root of b squared, which is 64 minus 4 times 1 times 12, divided by 2 times 1 is 2. Good. Yep, that's okay. We got x is equal to negative 8 plus or minus the square root of. And now what I should do is I should do, and you could even punch it on your calculator like this if you want. Your calculator, actually, if it's a Texas Instruments one like this, it does understand order of operations. So 64 minus 4 times 1 times 12. We get 16. Is 16 a perfect square? What's the square of 16? So we get negative 8 plus or minus 4 over 2. What is the largest degree of the, or what's the degree of the polynomial I started with? So how many solutions will I have? So let's figure them out. What's negative 8 plus 4? Negative 4 divided by 2? Negative 2, right? What's negative 8 minus 4? Divided by 2? So our two solutions are negative 2 and negative 6. Now in this situation, we could have factored it to x plus 2 times x plus 6. So you can see that if you do recognize that it does factor, that would probably be a faster way of solving it. But the quadratic formula works in all situations. Let's try B together, then you can do C on your own. All right, what's wrong with this from the beginning? What do I have to do? Good. Set it equals 0. 2x squared minus 6x minus 3 equals 0. What is negative b? Positive 6 plus or minus square root of square 6. 36 minus 4 times 2 times negative 3. It is so important that you remember to include your negatives. That will drastically change your outcome underneath the square root sign. The part underneath the square root is called the discriminant, and we'll talk about why that is in a second. 36 minus 4 times 2 times negative 3. We get 60. Can you take the square root of positive numbers? Yes. Can you take the square root of negative numbers? No, you get imaginary. So that's why it's called the discriminant. It tells us how many solutions we'll have. And if you come up with a positive number, you'll have 2. Come up with a negative number, there's no solutions. If you come up with 0, there's just one solution. So, can we reduce the square root of 60? Is there a perfect square that divides evenly into 60? 4. How many times does 4 go in? Look at your clock. How many times does 4 go in? 15 times, right? There's 4 15-minute segments in a hour, right? So it will be 6 plus or minus 2 roots of 15 over 4. And then in my final step of simplifying it, I look at these 3 numbers. Are they all divisible by the same number? 2. So divide them all by 2, and I get 3 plus or minus the root of 15 over 2. Try C on your own. Okay, try C on your own. I'm going to tell you that your answers will come up to be fractions without square roots. Your answers will come up to be fractions without square roots. Yep, try C on your own. we do? What part did you make a mistake on if you made a mistake? Which part? So the bottom is 2a. So the bottom is 2a, so you got to go twice 3. Anybody else? A spot where maybe you made a mistake. Okay, the 2a on the bottom. Okay. Sounds like that's kind of a common one. Any others? So everybody, if you didn't get 4, did you get a number different than 4? Okay. All right. So very good. All right. Reducing fractions, stuff like that. So a review of the quadratic formula. We'll leave D alone. It's the same type of stuff. And we'll move on to the last part that we want to do. So, hey, Nathaniel. So this is what we're going to spend a couple days on working in class. I would say of some of the stuff that we were doing first quarter and second quarter, I think that this is stuff that I saw that everybody needed a little bit extra time with. The quadratic formula, the square roots seem to go pretty well. So we're going to skip 5, and we're going to come back to that later on this week. And we're going to go to example 6, which is radical equations. So you can see that sometimes instead of a squared, you have a square root. And we're going to, treat this just a little bit differently. What do you think is the first thing I do to solve for a? I'm going to add the 3 to both sides. I get 4 times the square root of x is equal to 3. Now what do you think I do? Divide by 4. The square root of x is equal to 3 over 4. Now, if we had x squared is equal to 25, what did we do to get rid of the squared? What did we do to both sides? We square rooted it, okay? Those are what we call inverse operations. They undo each other. So if I want to get rid of a square root, what do you think I do to both sides? I square both sides. So to get rid of a square root, we square both sides. So I have x is equal to 3/4 times 3/4. When we multiply fractions, we go straight across. 3 times 3 is 9, and 4 times 4 is 16. So x is 9/16 is the solution. How about b? What do I do first? Add the 3. Get the square root of 5 minus x is equal to 3. You think I deal with the 5 first or the square root first? Square root first. How do I get rid of the square root? Square both sides. What are you left with? And now that's a basic linear equation that we were solving the other day. We can solve this. Subtract 5. Negative x is equal to 4. Divide by negative 1. X is negative 4. What do you think I do for letter C? Add 5. Let's see. To get rid of a square root, I squared both sides. What do you think I do to get rid of a cubed root? I cube both sides. And so that will make this cubed root piece go away. Get a 3x plus 1. Yeah, 5 cubed is 5 times 5, which is 25. Then times 5 again is 125. And now again, I have a basic linear equation. I subtract 1. And I divide by 3. And 124 is not divisible by 3, so we just leave it as 124 over 3. Last one, D. We kind of put everything together. First step. So I get 2 times the 4th root of 3x minus 2 is equal to 6. divide by the 2 first. Now what? How do I get rid of a fourth root? Fourth power. 3 times 3 is 9, times 3 more is 27, times 3 more is 81. X is 83 over 3. Okay, so we practiced really 3 skills today. One was solve by extracting square roots, so we square root things. Second of all, we use a quadratic formula. And third, we do radical, square both sides to get rid of radicals. We really have 2 things left that we have to cover, and these are kind of the 2 bigger ones. We have to be able to solve larger degree polynomials, and then finally, after that, we actually look at solving rational equations, okay? And we're going to have to take some work days in class in order to do that. So I do have an assignment for you today. It's not real long, but you do have about 15 minutes here in class to get working on it. If you need help with some other things, that's fine. Whoop. Oh. Page 22, 23, page 23. 71 through 78, that's 8 problems, and 93 through 98. That's 6 problems, and 153 to 158. And again, those are going to fall very similarly to what we did in class, okay? Like I said, you're going to get a couple work days this week where you don't get assignments in class, and should be able to help you get caught up on some things. So, all right.